Welcome back to another version of What Did You Miss During Live Session? This is our test review, so make sure that you are watching all of the videos in this series labeled Test Review. So for this practice problem, we're talking about taking an equation and making it into a graph. So over here, you're going to see the information that you will need in order to be successful. So the first thing it talks about is this leading term. Once again, we want to make sure that we know whether or not our leading term is positive or negative, and whether or not that degree is even or odd. So here, I want to find my leading term, and I'm going to do that by making sure that this is actually in standard form. I do that by making sure that my exponents are in descending order. I want to find the highest exponent. That's going to be the term that gives me both my degree and my leading coefficient. So 2, 3, or 4. 4 is definitely the highest one here. So I immediately know that my degree is 4, which is even. And then, because my degree is 4, I'm looking at this term. This term gives me both my degree and my leading coefficient. So my leading coefficient is -3, which means that I have a negative. So my LC is negative, and my degree is even. Because of that, I can go ahead and determine my end behavior. So because my LC is negative, that means my right-hand side goes down. Because my degree is even, that means my sides do the same thing. So that's the graphical version of what my end behavior is. With that notation, we're going to start with the left-hand side. We're going to say, okay, as x goes to negative infinity, well, y is going down, which is also negative infinity. On the right-hand side, so as x goes to infinity, y is also still going down, so it's negative infinity. So that is finding the leading term, and from that, the end behavior. The next thing it asks for is our zeros. But in order to find our zeros, we need factors. So in order to do that, we actually have to factor our equation. Now, the first thing I notice when I look at this is, well, actually, that is just kind of scary. But I know that I can do hard things, so I'm not giving up. I'm going to see that there is a negative in the front, so I'm going to bring that negative out. If there's ever a negative in the front, go ahead and factor it out. Now I'm going to look at each of my numbers, 3, 24, and 48. Well, I know that each of those are actually divisible by 3, so I'm going to bring the 3 out too. Next, I look at my variables. I see that each one has at least 2 x's, so I'm going to factor out that x squared. Now that I know that this is my greatest common factor when I'm factoring out, I'm going to divide each term by it to figure out what's left. So when I divide -3x4 divided by -3x squared, well, the only thing that's left is 2 more x's, so x squared. -24 divided by -3 is a +8. X cubed divided by x squared is just 1x. Our last term, -48 divided by -3 is +16. X squared divided by x squared, I don't have any x's left. So now I'm ready to finish factoring. I like to put something fancy around my greatest common factor because I'm going to leave it here for a minute, but I don't want to forget about it. I'm going to work on factoring this quadratic trinomial. Now, some of you guys might recognize that immediately this is a perfect square. Not a difference of squares, a perfect square. If you did recognize that and went immediately to the correct answer, you're good to go. I'm going to do this the long way out for the people who may not have recognized that. So the first thing we do when we're factoring this type of quadratic, or this type of polynomial, is we're going to multiply our a times c term, and that gives me 16. We're then going to identify our b term, which gives me 4. I want two numbers that, nope, it does not give me 4. Ooh, sometimes your brain doesn't work. It gives me 8. So I want two numbers that multiply to give me 16, but add to give me 8. Well, when I think of 16, the very first numbers I think of are 4 and 4. And you know what? 4 times 4 is 16. 4 plus 4 is 8. So yes, those are our magic numbers. So we're going to bust apart that b term. Now that I'm here, I can go ahead and group. Pull out the greatest common factor from each of these. So here's just an x. That leaves me with x plus 4. Here's just a 4. That leaves me with x plus 4. We know that if these parentheses match, they become one of our factors. And those GCFs become the other factor. Now this is really important. This is where we bring that major GCF from the beginning down. I am so close to being done here, but I noticed that x plus 4 times x plus 4, well, anything times itself is really squared. So it gives me negative 3x squared times x plus 4 squared. At this point, I'm ready to find my zeros. We find our zeros by setting our factors equal to 0. Don't worry about the exponent at this time. So I can say negative 3x equals 0, and I can say x plus 4 equals 0. That's going to give me x equals 0, x equals negative 4. So my zeros at 0, 0, and negative 4, 0. The very last thing to do is now, ooh, that was a bad color choice. Now worry about that exponent because we know those exponents are actually those multiplicities. So here, my multiplicity of 2, here, my multiplicity of 2. So I'm going to go bring that information over here. We did factoring to get there, so I have a 0, 0 with an m of 2, and negative 4, 0 with an m of 2. So I put the zeros and the multiplicities together. Once you have found all this information, you are ready to start graphing. I'm going to erase this factoring word so that we have room to graph. Now that we're ready to graph, the first thing that I ever do when I graph is I start with my end behavior because that tells me how to start my graph. So I'm just put these arrows way down here because I know that my ends are both going to be pointing down. The next thing I do is I plot my zeros. So I have one at negative 4 and one at 0. Now I'm ready to sketch. And I'm going to say with my mults because I know that my multiplicities are going to tell me what to do. So starting from my end behavior, I know that I'm starting down. So this is the quadrant I'm going to start in. I'm going to start down here. And I'm going to come up towards that negative 4. As I get here, I go, hold up, wait a minute. What was the multiplicity there? Oh, it was a 2. So I know that even multiplicities bounce. So I'm going to hit that x-axis and I'm going to bounce and turn back around. Now I'm ready to do it again. I'm going to try and get to 0. So I know in order to get 0, I have to turn around. I'm going to come up to 0 and I'm going to do the same thing. I say, hey, what was that multiplicity? Well, that multiplicity was 2, so I'm going to bounce again. I'm going to go up to it, I'm going to hit it, I'm going to bounce and turn back around. At this point, I go, okay, don't have any more zeros, so I don't need to turn back around. And if I were to draw arrows on my graph, they match the arrows that I had for end behavior. So you know what? I'm done. And that is how you can take an equation and sketch it. As a reminder, at this stage, we had to factor your polynomial. And there you go, taking an equation and getting a quick sketch of the graph.